So yesterday we started this idea of solving literal equations. Today we finish up this idea, and so this is just an extension on what we did yesterday. In fact, I believe all the objectives are identical to what they were yesterday. The why am I learning this, though, is different because there are many reasons why we need to know this, and systems of equations, which is coming up in Unit 3, we'll utilize this idea again. So, from yesterday, remember when you're solving any equation for any variable, you need to remember all the steps that we have learned in the past. You know, sometimes we may need to use this distributive property, or the addition or subtraction property, or the multiplication or division property. We may even have to combine like terms at some point, but all of those things that we've talked about in the past still apply here. We talked about what a literal equation was, and if you went back and looked in yesterday's notes, you had to copy down the definition, and here were a couple of examples that we did in the notes yesterday, where we're solving for a different variable. This is n given in terms of q and c. We talked a little bit about this. We solved this one for d by adding 7c to both sides, and then dividing both sides by 5, and we now have d in terms of p and c. And then we also talked about the fact that when we're solving for y, when we have y and x in the same equation, when we're solving for y, that's called slope-intercept form. But the steps that we utilize are identical. And sometimes this slope-intercept form is called y equals mx plus b form. And that's just a generic form of what we're trying to create. So here is our first new problem for today. Number one, we are trying, and for every one of these, we're trying to solve the equation for x. And the point today is very simple. Look at number 1 and number 2. They're almost identical to each other. 3 and 4 are almost identical, and so on. The point that I'm trying to make here is that whatever you do in number 1, you're really doing the same sort of things in number 2. So, somebody give me a suggestion on what we should do for number 1. And we have encountered that exact kind of equation before. Yes?
Make it 7 over 1 and cross both sides.
So you wanted to do it as a proportion, and that would be fine. What's another way of dealing with this?
Multiplying by 5.
Multiplying both sides by 5. Now, I don't care which way you do it, but I would like you to go ahead and solve for x. All right, Goggin, what'd you get for number 1?
I got
X equals 11. Very good. And since we've done that kind of equation before, I'm kind of bypassing the work there. But now I would like everybody to do number 2. And my advice to you is, however you did number 1, I would do number 2 exactly the same way. And what I'm saying is, if you turned 7 into 7 over 1 so that you would have a proportion, then do number 2 that way. If you multiplied both sides by the common denominator of 5 in number 1, then do number 2 exactly the same way. Okay, so for a quick show of hands, and this will tell me which way I probably should do this, how many of you are doing number 2 by multiplying both sides by the common denominator of 5? All right, how many of you are using a proportion? Okay, so more of you are multiplying by the common denominator. So that is the way that I'm going to do number 2. So if you multiply both sides by 5, because that is the common denominator, here's what we have. When we do it that way, the 5's cancel on the left-hand side because 5 over 5 is 1. And so we have 3x plus 2y equals 35. And now it's exactly like a problem that we did yesterday. Remember, we are solving for x. So I need to subtract 2y from both sides, which gives me 3x equals negative 2y plus 35. And then we should divide everything by 3, and that would give us x equals negative 2/3 y plus 35/3. Any questions there? Okay, I would like Ferrum.
What if it, never mind.
Yes.
What if you put x equals negative 2y plus 35 over 3?
And that's kind of where we were going yesterday, but at this point I want you to split it up because we're getting ready for this idea of using slope and y-intercept to graph linear equations, okay? All right, everybody do both number 3 and number 4, please. So right now, we're essentially applying all these things that we've been talking about the last couple of weeks. We're kind of putting it all together. And it all started yesterday. When I walked around, I was looking for how people were doing things. Because there's always really a lot of different ways that you could solve these equations. What most of you did in number 3 is you multiplied everything by the common denominator. That's what I would do. But there's nothing wrong with adding 5 to both sides and then solving it that way. That's okay. But regardless of how you did that, Autumn, what did you get for number 3?
I got x equals 12.
X equals 12, and that is what I saw from most of you. And in number 4, since it's really the same sort of thing, most of you multiplied everything by 3, which will give you 4x minus 15y equals 33, and then you solved for y. And Athena, what did you get for that one?
X equals 33 over 4 plus 15 over 4y.
Okay, so the only thing that I recommend for you is please put the 15 over 4y first. Okay? And so the answer that I put up here is not the way that I want you to write it. The way that I really want you to write that is x equals 15/4 y plus 33 over 4. That is really the way that I want you to write that one. Okay? All right, I would like everybody to do 5, 6, 7, and 8. Do all 4 of them, please. Hopefully it's obvious to you in all 4 of these, you really should probably use the distributive property first. All right, Max, number 5. Very good, x equals 12. Number 6 should be what, Danielle?
I don't have an answer.
Did your shoulder partner have the answer?
Yeah.
Okay, so that means that really you should have the answer, right?
Yeah.
Okay. Elijah?
For number 6,
Yes.
x equals negative y plus 6.
Plus what?
Plus 6.
Oh. Plus,
Wait. It's plus 30.
plus what?
30.
I'm not sure.
I got x equal to negative y plus 15.
Plus 15, yes. And so what did you do, Elijah? Did you use the distributive property first?
Yeah.
That's what I would have done, which gives you 2/5 x plus 2/5 y equals 6. Then multiply everything by the common denominator. I'm trying to squeeze it in there, but that would give you 2x plus 2y equals 30. And then subtract 2x from both sides and then divide everything by 2. That's where the 15 comes from. And so while I have this up here, the preferred version, of course, is x equals negative y plus 15. That's the preferred version. All right, how about number 7, Ivan?
X equals 2.
X equals 2, very good. And then how about number 8?
X equals 2y.
X equals 2y, very good. Any questions about any of those? Yes.
Yeah, number 8, I didn't quite understand how to do that.
Did you do the distributive property first?
Yes, and I got 6x plus 8y. So we have 4x plus 12y.
Okay, then what did you do?
Then I thought I would subtract 4x,
Okay, so then what did you have after you subtracted 4x?
2. 2x plus 8y is equal to 12y.
Okay. Then what did you do?
Then when I subtract 8y,
Yes?
that's where I got stuck. Alright.
Yeah, so then that would give you, after you subtract 8y, and I know I'm trying to squeeze all this in here, but that gives me 2x equals
4y.
4y. We're solving for x, so we have to divide both sides by 2, and that's how we get x equals 2y. Okay? We good?
Yeah.
All right. So our last two problems for today are these two problems, and in both of them, you are solving for x. And then when you shoulder partner, I'm framing up what I want you to say, which is first I did this because, then I did this because, then I did this because, and hopefully that's enough steps to get you where you need to be, but if not, you may have to do another one. So go ahead and do both. 9 and 10. Obviously, when we shoulder partner, the ones will take 9. And remember, I have sentence framed it up for you, and that's the kind of thing that I expect to hear. Go.
Yes.
All right, so I just had you shoulder partner every step on both of these. So number 9, you have several possibilities here. You could have multiplied everything by the common denominator, which is c. You could have added d to both sides first. It doesn't matter which one you do. I am going to add d to both sides first. So now I have ax plus b all over c is equal to d plus e. I rearranged because of the fact that typically we like to put things in alphabetical order. Now remember, we are solving for x, and I realize I just put a c or an x down there and it should have been a c. Thank you. So now I probably would multiply both sides by the common denominator. So multiply by c, multiply by c. The c's will cancel on the left-hand side, and I'm left with ax plus b equals cd plus ce. From there, remember, we are solving for x. We're trying to get x by itself. So hopefully it's obvious to you that we would subtract b from both sides. That would now give me ax equals negative b plus cd plus ce. And remember, I like to put things in alphabetical order, and at some point we're going to have to make sure that we do that. We are solving for x. For x, so I would divide everything by a. And so it would be either x equals negative b over a plus cd over a plus ce over a, or x equals negative b plus cd plus ce all over a. Yes?
Would it be okay if I put x equals ec plus ec minus e over a?
And once again, that's okay for right now, but at some point we need to make sure we get things in alphabetical order, okay? Any questions with that one? All right. Number 10. Really, same kind of things that are happening. You could multiply everything by n first. And in fact, you know what? In this one, that's what I'm going to do. I'm going to multiply everything by the common denominator first. So that gives me mx plus sn equals tn. And then I would subtract sn from both sides. That gives me mx equals negative sn plus tn. Once again, I rearranged it because I like to put things in alphabetical order. And then divide everything by m. So you would have x equals negative sn over m plus tn over m, or x equals negative sn plus tn, all of it over m. Any questions? So if you could get both of those right, you can get anything right, because those were made up of a multitude of variables. Okay? All right, we are finished for today.